Hey folks, in this video we are going to be talking about plane mirrors. Plane like a geometry plane, meaning flat. These are the boring type of mirrors, but they are also the common type of mirrors. So what you got hanging up in your bathroom right now, for example. As opposed to curved mirrors like your funhouse mirrors, where you can do really cool and interesting things. That's where the fun physics is. But the plane mirrors should be our starting point. So we'll start there. So we're going to talk about an eye person, which you'll see what I mean in a second, and we're going to see how they see their reflection. Here is our eye person. It's a person, but their head is just a gigantic eyeball. And the point is we're talking about seeing reflection, so we want to focus on the eye part. All right, so there's our eye person. They're going to be what we consider our object, the thing that is being reflected, or whose image is being reflected by the mirror. Here is our plane mirror. It is a mirror, it is flat. How does this eye person see themselves in the mirror? What's going on? Well, let's first consider their feet. Somehow, to see their feet, light rays from they're bouncing off of their feet must get into the eyeball of our eye person. So, there are light rays going off in all directions from the person's feet, but some of those light rays are going up at this angle. And it's the exact angle needed such that when it reflects off of the mirror at the same angle, the light rays enter the person's eyes. And so that's how the person sees the reflection of their feet in this mirror. What about like their hands or torso in the middle? Same idea, a light ray. Some of the light rays reflecting off of that person's torso are at the correct angle such that when they bounce off of the mirror, those light rays make it into the person's eyes. Our angle of incidence is equal to angle of reflection. My drawing is not perfectly to scale, but that's the idea. Similarly, in order for the eye person to see the reflection of the eyeball, some of the light that's bouncing off of the eyes are going to hit the mirror and come directly back into the eyeball. Now, here's the problem, though. The eyeball only has information about what's coming into it. The eyeball doesn't have any information about what's happening at the mirror. In other words, the eyeball, because it's localized to just this point, has no idea that there was a reflection off of the mirror. And so the person sees that this incoming red ray, the eyeball interprets it as if the origin of the ray were somewhere behind the mirror. Of course, we know that it's not. It's the person's feet. But the eyeball interprets the origin of that ray as if it were behind the mirror. Similarly, for this purple ray, the eyeball doesn't know that it bounced, so the person interprets the origin of the purple ray as being behind the mirror. Similar for the yellow ray. And so overall, the eyeball is interpreting all of these incoming rays as if they were coming from an identical image on the other side of the mirror. And we call that identical image a reflection. Image is the word that we will use more often in this class. But that's the idea, is the light rays from the feet, torso, etc., reflected off of the mirror. Your brain and eyeball doesn't know that there was a reflection, and so they interpret the origin of those rays as being from the other side of the mirror. Check it out next time you're in the bathroom, next time you're near a mirror. If you haven't noticed this before, and really pay attention to the reflection, it will look like the objects, the images on the reflection of, what I'm trying to say, it'll look like the reflection on the other side of the mirror, all of the objects, it will look like it's behind the mirror, as if you could push through into the mirror world and you'd be there in some reflection on the other side. Some things to note, for a plane mirror, a flat mirror, the distance between the mirror and the object, called the object distance, and then the distance between the mirror and the image, called the image distance, those are the same. Similarly, unlike in funhouse mirrors that are curved, the height of the object is the same as the image height, is the same as the image height. The height of the image ends up being the same as the height of the object. So for plane mirrors, the image forms behind the mirror, the object distance is equal to the image distance, and the object height is equal to the image height. These are maybe things that are that you've noticed before but never paid that close of attention to, You might be thinking, yeah, of course the image height is the same as the object height. But keep in mind, again, for those weird curved mirrors, that's not true. That's what makes them interesting. Or the side view mirror on your car, it says objects in mirror are closer than they appear, right? The image in that mirror is smaller than the actual object. And so it's not always the case that the reflected image has the same height and same distance from the mirror as the actual object of origin. It's true for plane mirrors. We're going to look at other mirrors next where that's not true.